So you ready? Okay. Okay, so I'm just telling a story, answering a question. You're coming in the middle of it, but we're talking about the science of fracture mechanics. So the toughness, according to Griffith in 1925, was greater than the stress times the square root of pi times the crack length. And A is the flaw size. And he knew that in glass, you can just scratch glass in it with something that's 25 microns, a thousandth of an inch deep, and it just makes it brittle as can be, okay? And so Griffith was trying to understand, and he did an energy of fracture criteria, that the strain energy must be stored in the thing that you're bending or pulling on, must be greater than the ability to create two new fracture surfaces with their surface energy. That's how he did it. So in World War II, after the Liberty ship failures, the Navy learned that it's not just the strength of a material, it's the energy of fracture. And you have to understand both if you're really going to understand fracture of materials. So, turns out a guy at the Naval Research Lab, George Irwin was his name, was head of the mechanical engineering department. And he took on this problem in 1946. And he is now known as the father of fracture mechanics, even though Griffith had worked on it 25 years before. Okay? Because he showed the same equations could be applied to metals as well as glass. So your question was about, can it be applied to glass? Well, it was first applied to glass and then applied to metals. And so, I mean, fracture, and Dr. Belmar is an expert on fracture mechanics, okay? I teach it some, okay? And we can talk about that later, okay? That's an aside. Yes, question?
How does it apply to elastoplastic materials? I mean, I know there is a different index that is J rather than K.
Right.
What's the connection?
So there's a guy at Harvard named Rice, John Rice, I think, anyway. And he came up when he was a graduate student doing his thesis at Brown University, I think. Maybe he was at Lehigh, and then he became a professor at Brown. And then he was elevated. He was called to the professorship at Harvard. And by the way, that's how it occurs, okay? At Harvard, they call you to the professorship. It's not quite that way, but in the old days, you were called to be a Harvard professor. Anyway, he came up with a criteria of the J integral. And for very, very tough materials, you can't use the Griffith criteria unless the materials are very, very large. I mean, for a very tough material like you would have for we were talking about bullets and penetrators, very tough materials, you might have to have something 2 feet thick in order to do the fracture toughness test. But the J integral is basically just a fancy way of looking at the stress-strain curve, which looks like this, and integrating the energy underneath it. And the mathematicians have made this so complex that no one else can understand it, okay? Certainly not me. But the modern thing is the J integral, okay? And certainly when you get to very, very plastic materials like elastoplastic polymers and stuff, you're going to have to use the J integral. But since Griffith in the 1950s and 1960s in the science of fracture mechanics, Rice came along in the 70s, developed the J integral, and everybody does that. And in the world of mechanics, structural mechanics, there's Jim Rice up here, and the next person is down here, okay? I mean, Rice is an order of magnitude above everybody else in understanding fracture in the world. He's probably about 80 now, but or maybe late 70s or so. I mean, he's still around. But he's moved on to fracking, although he was doing fracture of rocks and tectonic plates as a fundamental scientist well before we got into fracking. He was doing that in the 80s and 90s. And he really is a superstar.
He's still a professor at Harvard?
Yeah, but he's emeritus now, I think. But he's incredible if you actually look and see what he's accomplished. Other questions? Okay. So I do say something nice about some people, but anyway, I'm going to go through a very brief, since it's been a week, since I was away for a week, I'm going to go through a very brief review of the last lecture, Total Quality Management. Is it a revolution in manufacturing? Some people think it's garbage. Some CEOs think it's the greatest thing since sliced bread. I went through and gave you some references, told you the story about Tom Lee and what the difference is in managing it at a university versus managing an industry or a big international governmental agency. I talked about the TQM challenge and going to IBM to learn about customer-driven quality and how they had a quarter of their workforce was doing negative value added. And have been giving you some books and some reading if you want to follow up on it. You're not quizzed in this course, so you don't have to follow up on it, but I've been criticized by students in the past of, I don't tell you how to go learn more on your own. Well, you shouldn't have to do that. You're MIT students. You ought to be able to figure it out on your own, but I'll give you some hints. Okay, it doesn't cost me much to give you hints. Okay, where did TQM come from? Today we're going to talk about, it goes back to people like Henry Ford and others 100 years ago. I actually trace it to the Navy's Thresher disaster in the early 60s. If you look on Wikipedia, you'll find it's, they say it was the Navy in the mid-80s, but in any case, whether it's 60s or 80s, turns out the U.S. Navy did go into good manufacturing practice and used the term in the 80s as the first source of the term, according to Wikipedia. But there's something now getting into where I wanted to be, something called lean manufacturing. And lean manufacturing came out of MIT. And I don't remember if I passed this around. This is Dan Roos's book. Dan Roos was a faculty member in civil engineering, and he had a $1 million a year program in the 1980s, big program, to study the future of the automobile. Okay, he was in transportation, and he was the big world guru. He knew all the CEOs of all the major automotive companies in the world. And he came out in like 1988 with some co-authors who were the primary authors. But out of their study, they came up with this book called The Machine That Changed the World. And they're talking about the Toyota production system. This is when Toyota was building better quality cars than anything out of Detroit. They still are. But anyway, and how they did it, and the principles that Toyota used. And Kent Bowen, who was headed up he founded the Leaders for Manufacturing program, which is now the LGO, and he left as being a ceramics professor in this department left to Harvard Business School, and he taught the Toyota production system. Okay? And he's retired. Haven't seen him since yesterday. But in any case. But the term lean manufacturing was coined in that book. Okay? No one had ever used it before, Dan Roos and his co-writers. Well, so I'm going to tell you this story of infighting at MIT, and that's where I had left off. And there were a number of people, 4 people at the top, that was a fight between mechanical engineering and materials engineering. The first 2, Cook and Sue, were very powerful people in mechanical engineering, started the Lab for Manufacturing and Productivity, which still exists. And then Mert Flemings founded the Materials Processing Center in this department, and they were just sort of mortal enemies, okay? As a young, untenured assistant professor, I got caught in the middle of the crossfire, okay? Kent Bowen comes along. He was asked by the Dean of Engineering to start a manufacturing program. In 1984, he started raising money. By 1989, he had $50 million, all from American industry. MIT was going to redefine manufacturing. And so Tom Magnani was a professor at the Sloan School of Management, been denied the job of dean twice. He was aspiring to become an administrator. And he and Kent Bowen started this program. There were 19 LFM professors. We got term chairs, and Dave Hart was one, I was one. A couple of young guys who had just graduated under Warren Searing in mechanical engineering with their PhD in design, product design, were hired by the Sloan School of Management. Okay, Carl Ulrich, who had done a bachelor's thesis with me, and Steve Eppinger, who has since become deputy dean at the Sloan School, and many other people. Carl Ulrich did not get tenure because he was not a real management school type of person. He really crossed the boundaries between engineering and management. And so it turns out he didn't get tenure in 1995. I was a department head at the time, the dean of engineering, who became the provost. Joel Moses assigned me to write a report on what should be done if we can't tenure someone like Carl Ulrich, who's now a full professor at Wharton, okay? What he's really known for, you know, all the little scooters, the little two-wheel scooters kids ride around on? Carl didn't invent it, but he was the guy who brought it to the United States, and he was selling and making them in his garage in New Hampshire and selling them, so he made quite a bit of money. His mother is a university professor at Harvard, which is kind of like an institute professor here. She won the Pulitzer Prize. Interesting family. Anyway, so the people on the lower part, we're just the flunkies, the worker bees, and the people at the top were the main ones. So Kent Bowen in 1993 goes off to Harvard. I become head of the engineering director, along with Tom Magnani, one of the founders of the LFM program. And it turns out for 4 years, Dan Roos was the guy to the outside world in lean manufacturing. And we had these guys from industry as part of this $50 million program, and his name was never mentioned. Okay? This was the internal politics. And I become the engineering co-director. I said, so in one of my first meetings, I said, so Dan Roos is just 2 floors below us in E40. Okay, we were on the 5th floor, he was on the 3rd floor. I said, how come we don't bring him in to talk to our governing board? Oh no, you can't talk to Dan Roos. Excuse me? Why can't we talk? I mean, on the outside world, Dan Roos was the face of lean manufacturing, which is now a big thing around the world. And we were the $50 million, now $70 million manufacturing program. No, you can't go talk to him. Knowing me, I said, well, I'm going to go talk to him anyway. Okay? They were ripping, okay? These people could not stand that I was going to defy them and go say hello to Dan Roos. So I make an appointment, go see Dan Roos. Dan welcomes me with open arms. He obviously had been sort of chagrined that he had been cast aside when he was now the big name on the outside, and he couldn't even participate in this $70 million program because of the internal politics, okay? So when I talk about total quality management, and Steve and I discussed this, you need to know that MIT has big warts, okay? We're like any other organization. I'm not saying that MIT is terrible. You'll find that I actually think MIT is not bad. But we have our warts, okay? And any organization you're going to be in, you're going to find some warts. Okay, so something that's worth reading or scanning or spending a little time. If you just look up total quality management on Wikipedia, the fount of all knowledge, they have a whole series of articles about total productive maintenance, theory of constraints, lean manufacturing, Six Sigma, zero defects. So you got 15 minutes, go read them. Give you, I don't want to spend the time lecturing to you about what these things are. They're all buzzwords in the business world for things that fall under total quality management. Am I doing okay? We're okay? Okay. Okay, forerunners, and I said something wrong. I was looking again at some of these articles this morning. Frederick Taylor actually died before Harvard Business School was started. He was not at Harvard, he was at the University of Pennsylvania, but nonetheless, he was the father of scientific management. The person who coined the term scientific management was a guy named Louis Brandeis, in an opinion he gave in 1915 from the Supreme Court. Or no, before that, before 1910. And then Frederick Taylor wrote a book in 1911 called The Principles of Scientific Management. He picked up the word from Brandeis. Who was Brandeis? He was one of the most famous Supreme Court justices in the United States. And we have a university out west of here named Brandeis University. Okay, anyway. But I mean, along with other great Supreme Court justices, like, you ever heard of Oliver Wendell Holmes? He was a Supreme Court justice, okay? And he said a lot of famous things from the bench. Anyway, there are others. I can't go through. Steve can cover that and give you a history to talk about great lawyers. Okay. There's Henry Ford. You kind of know what Henry Ford did, but you can read about it. And Saiki Toyoda. Who's he? He is the father of industrial manufacturing in Japan, and he ran a company that made sewing looms. In 1925, they offered a $25 million bounty on anyone who could come up with something better than the lead-acid battery. $25 million in Japan in 1925? That's like offering, $500 million as an award today, because you needed a lead-acid battery for reliability in running these looms. And he was trying to come up with a more reliable system for his customers. In any case, I would suggest you look them up on Wikipedia to learn more what they did in manufacturing. Again, I'm not going to lecture to you about them, but these are three early leaders. Okay, these guys were 100 or 150 years ago. They were doing things that were unique in manufacturing. And a lot of the principles that they worked on and taught are what we call total quality management today. Okay? So total quality management is a new term. And that's why some people think it's garbage. It's just a bunch of buzzwords. But some people say, well, these are important principles. One of the people who taught some important principles was a guy named Douglas McGregor, who I understand. How many of you are from Sloan? Okay. You haven't heard of Douglas McGregor, have you? When Alfred Sloan of the Sloan School, who was Alfred Sloan? What was he famous for?
He ran the largest corporation in the world for 50 years, General Motors.
Called General Motors, right. And he was an MIT grad. And he gave a tremendous amount of his fortune to MIT. In the early 1950s, he gave a bunch of money to MIT for teaching principles of management, scientific management, it was known at the time. And MIT took this little department that was in the School of Engineering called the Department of Business and Industrial Development, which sort of taught industrial engineering type things, and they created a school and named it after Alfred Sloan. That's how the Sloan School of Management got started. About the same time, a new dean of engineering, I have to stop and think of what his name was, in the 50s decided MIT should just do scientific engineering. They didn't want to do any of that practical stuff that real engineers do. And so they sort of took all the practical stuff out of the School of Engineering. Some of it went over to the Sloan School. The Sloan School kind of went along their way, kind of trying to upstage, if they could, Harvard Business School, the competitor up the street, and that still goes on. I remember in 1988 when I took the Sloan program for senior executives. This is a 9-week intensive program where you spend like 80 hours a week learning management. So I have a Sloan degree. No, it's not a degree. I guess, I don't know if it's a certificate. I got a coffee mug with my name on it. Anyway, that's almost as good as a degree, right? In any case, someone asked Ed Schein, who was a protege of Douglas McGregor. He was teaching, and someone says, we were going to have dinner with the Harvard Business School executive education guys taking their 13-week course. And someone says, what's the difference between Sloan and Harvard Business School? And Ed kind of stops and scratches his chin, and he says, well, Harvard's sort of the West Point of business schools. Have I told this story? No, okay. Harvard's sort of the West Point of business schools. They teach case methods, which is how it's been done in the past. You know, and you know, at West Point, if you're going to have a tank battle, they teach you what happened in the Arab-Israeli war, right? They teach you the history, and you're supposed to infer the future from the past. Whereas he says, well, MIT's more of the Bell Labs of business schools. And in fact, that's exactly what I found when we went to the IBM Center for Quality Development. It turns out they were talking principles at us for a week of business school practice. And half a dozen of the people who wrote the books on those subjects were MIT faculty sitting in the audience. Okay? And the guys from IBM didn't. They talk about, well, so-and-so wrote, and there he was as your student. Okay, it was kind of funny, but anyway. So Douglas McGregor in the 1950s wrote a book called The Human Side of Enterprise. And you have the pointer, my pointer up there, the blue, yeah, one of those blue things.
These works.
Yep, thanks. Okay. Oops. Yeah, should be working. Okay. So let me go over here, because I just stole this from the website. Theory X is about the way General Motors used to treat its employees when I was working with, I didn't work for General Motors, but I interacted with them, where people dislike their work. They've got to be forced or coerced into doing their job. You don't give them any responsibilities, per se. You let management tell them what to do. And Theory Y, and that's what Douglas McGregor called these in his book, we need to work. If people actually want to work and they want to take an interest in what they do, they'll direct themselves towards the target that we accept, or our goal. So there's these different attitude, direction, responsibility. So there's the negative view of the worker B and the positive view of the worker B. This was a revolution in management in the 1950s. If you look it up, you'll find The Human Side of Enterprise is considered one of the top 25 business books ever written. Part of it was Alfred Sloan working directly with Douglas McGregor. Okay? And in any case, we don't have to get into all those details, but Douglas McGregor wrote this book, which, as I now have polled a couple of people, they don't even mention him anymore at the Sloan School, because everything kind of goes back to its lowest common denominator, where they treat us all like dirt. Okay, but one of the principles of TQM is the principle that Douglas McGregor taught, and a few other people. It's worth looking at, or at least browsing, Douglas McGregor's book, okay? There's an annotated edition, which is the one I'm handing around, and it's got some lengthy forewords and things by some other Sloan people who are some of the leading lights in manufacturing and how do you manage people and things like that. But the whole idea of treating people well goes back thousands of years. And to take a few people that you've heard of, Andrew Carnegie, take away my people, but leave my factories, and soon grass will grow on the factory floors. Take away my factories, but leave my people, and soon we will have a new and better factory. So Andrew Carnegie understood it, okay? And then here's a quote from one of the books from 1985 on total quality management. This is an executive of CBS Sony Records, which this Japanese Sony, this is when Sony was not so big, but Sony bought CBS, I guess, was the way it went. And it's from What is Total Quality Control. He said, the difference in the quality of sound of their records, this is the old 33 and the third RPM records, comes from our people and not from our machines that are stamping out these records. Okay? It's the people, and the people want to make a good product. As I often say, I don't know anyone who goes home at the end of the day saying, I did a lousy job at work today and I'm proud of it. Okay? What they're more likely to say is, unfortunately, I did a crappy job at work today and it's not anything I had control over. I did exactly what I was told because if I didn't, they would beat me. Okay? In some figurative way, right? The thing is, if you actually learn to trust the people you work for, you can gain their control. Okay? There's a couple other quotes, which one I always tell my LFM students, LGO students, when we go out to the companies, I say 90% of the problems, manufacturing problems, are not technology problems. They're people problems. When Kent Bowen and Tom Magnani started the LFM program, it was supposed to be an equal partnership, 50% management, 50% engineering. And I was one of those engineering professors. I was supposed to go out there and teach Motorola how to do better technology. Bull. Motorola already knew better technology way ahead of me. They didn't necessarily know better ways to manage people. Okay? My grandmother knew better ways to manage people. Okay? But anyway. And Charlie Fine, who was a young assistant professor at the time, how many people know Charlie now? You don't see him at Sloan as much. He's a full professor. And a few years ago on the MIT 510K form or whatever it's called, that they have to, MIT has to report to the Securities and Exchange Commission because we're a corporation, and we have to name the top 10 earning people at MIT. Charlie Fine was number one. He made just under $1 million. And that was because he was teaching the executive education programs on supply chain management. And unfortunately, I just did a survey, and none of you get to know Charlie anymore because he's now elevated to the big bucks. Okay? But he's a great guy. But we used to supervise students together, and he said, there are $100 bills laying on the floor of manufacturing plants. If you want to get rich, just go out there and pick them up. And I will tell you some stories about some of those $100 bills and how I picked them up and handed them to other people because they wouldn't let me keep them. That's part of intellectual property. Okay? So I'm now going to tell you a couple of stories. One's about the mad shitter. So I had an LFM student, LGO student, and she was assigned to a Honeywell plant. And I shouldn't have said Honeywell, but I said Honeywell. Anyway, Honeywell had acquired this little business, mom and pop operation that made plastic film. You know, like, it's sort of like the stretch wrap that you might wrap pallets in and stuff today. That's not what they were doing, but it was big machines like that. And so she had been assigned to do her internship at this plant. And we went down there, and it wasn't a terrible building. You went inside, they had stacks of bad inventory just going up 2 stories, high, these rolls of plastic. They had this big $3 or $4 million machine that could create the plastic film. And you look over at the toolboxes, and they had big padlocks on them, okay? That's because the workers didn't trust each other. They would have their tools stolen by their coworkers. The management hated each other, and they told us the story of the mad shitter. It's a true story. There was a problem in that sometimes they go to do the custodial things in the men's restroom, and one guy had been in there, and he must have used rubber gloves or something, I assume, but he had taken his excrement and he just rubbed it all over the walls. Okay? And so I can't remember the student's name right now. Sorry. I can see her in my mind. I'm terrible on remembering names. So this is what we were going to send her down to for 7 months. Okay? And I said, after we had done our little pleasantries and learned about her internship, I said, let's stop at the diner up the road and have a little, I drink orange juice and she drank coffee. And so we went up there. I said, so what are you going to do about this environment, this people environment you're going into where it's just war going on between management and the hourly workforce and among the hourly workforce, okay, padlocks on their tool chests and stuff. Clearly, it's not going to be a very productive, happy situation, okay? And she says, well, I don't know. And she had actually worked in industry. She had about 8 or 10 years of experience, but not in a factory like this. I said, I know what you're going to do. Why does someone go rubbing their excrement on the walls? Because they're completely frustrated. No one's listening. So they're trying to get attention. It might be immature, but it doesn't matter. You're going to find a lot of immature people in your life. So what are you going to do to change that? I said, I'll tell you what you're going to do. Every Friday, this is what Steve is doing for you. I said, every Friday you're going to come and get donuts. And you're going to bring them in. And every day during the week, you're going to go out there in the factory floor as the new person and say, what can I do to help you? Just ask them, what can I do to help you? And at first, they're not going to tell you because they don't trust management. And you're part of management. But some of them will tell you, or what frustrates you? Just ask that question. And it might be something simple like, we never have any coffee for our coffee shop, or we never have any sugar, or something, okay? And you're going to go solve that problem. They may tell you some other bigger problems that there's no way you can solve walking in as a new person. But there's going to be some simple problems that you can solve. And every Friday, you're going to bring in donuts for those hourly workers, and you're going to put them next to the coffee stand, okay? Within 2 weeks, those big old guys had their arm around her, showing her this and that and what was wrong. And she was able to have a wonderful internship, and she worked with those hourly workers great. It was a great relationship. They loved her. And she would go back to management and say, by the way, did you know that if we do such and such, the workers knew what needed to be changed in that plant, but no one had been listening to them. So what do? They start, spreading the excrement on the walls, right? So it worked. It's a great internship. And she added some value, and she was happy to get out of that place. Okay, the other one is Alcoa, Tennessee. Alcoa, Tennessee is on the Tennessee River near Knoxville, Tennessee, between the airport and Knoxville itself. And it's called Alcoa because back around 1900, Alcoa went down there because they had low-cost electricity to smelt aluminum ore and turn it into aluminum. And they had, at the time, I think it was the world's largest aluminum can production plant. Okay? I mean, making aluminum for Coke bottle or Coke cans and stuff. And the people in Tennessee kind of have long memories. I was born in Chattanooga, folks. Okay. I'm an East Tennessean. And back around 1910 or something, they had had a strike, and Alcoa brought in the Pinkerton Guards, which is sort of typical of labor relations at the time. And someone among the Pinkerton Guards shot at the people who were the union that was being locked out or whatever. A couple of people died, and even when I went down there in 1990, the hourly workers still called it the murdering Alcoa, okay? They had a memory from 80 years before about how their grandfathers had been killed by the Pinkerton Guards. And there's plenty of stories from that time of other Pinkerton. Pinkerton was the people you brought in. They're the BlackRock, okay, that's BlackRock Financial. What's the guys who go over and ran the prisons in Iraq and stuff? Anyway, our mercenaries that we pay. But they were the mercenaries who would go in and clean house for the captains of industry 100 years ago. So they called it the murdering Alcoans. They had just finished a strike about 4 or 5 years before in the late 1980s. And typically today, what happens when you have a strike in a critical facility, they'll make the management people come in and start running the plant, okay? One of my favorite stories on that is there's this power plant right across from the new Wynn Casino over here in Everett. Used to be owned by Boston Edison. Now it's probably National Grid or somebody. And they had a strike, and they brought in people from downtown. And one of the engineers from downtown who used to design, things for the plants comes in. He's now got to go up and down this 8 or 10-story building to do the work to turn the valves and everything. And he walks in and he says, "Boy, it sure is big," as he looks up at this huge boiler. And the foreman, who's one of the regular workers in the plant, says, "Well, you designed it." Okay. You don't even know what you designed, you idiot. Okay. And anyway, so at Alcoa, this guy went and told, he was working in the plant, and they used to have meetings of the management people about who's going to take care of what the next week and stuff during this strike. And he says, "Gentlemen, I want to tell you what the strike is about. I had been working for 16 hours. I was about to explode. I needed to go to the restroom. And I was heading towards the restroom, and my manager said, 'Go over and fix this thing over here before you go.' And I did. Finally get to the restroom, get in, close the stall door, sit down, and I get this big cut from the splinters on the wooden toilet seat. I'm bleeding. I do my business, and I reach to find the toilet paper. No toilet paper. Gentlemen, this is what this strike is about. Okay? So there's the mad shitter story. There's the other guy who's not necessarily a mad shitter. He's just a very bloated shitter. I don't know. But you can find stories. I got other stories like this. I just figured I could put those two together because most people are just shocked by the idea of a mad shitter. But you have to ask yourself, why are people acting like this? What's motivating that type of behavior? What's motivating is you, the management. Okay? Okay, so I'm going to change topics now. We've had enough about restrooms. Anybody have any questions? Okay. So when I say the problems are people problems and not technology problems, what has happened to the LFM program? It became the LGO program, and now it's a Sloan program, and there's almost no engineering faculty who participate. Why? We were irrelevant. The companies didn't need our technology. They needed how to learn Douglas McGregor's principles of the human side of enterprise, and they still do. Although some companies are actually pretty good at it, but not all of them. So this is, if you go and you ask for images of quality on Google, this is the garbage you get, okay? What's the content in that? Okay? This has got words in Six Sigma, that's a little more content. This image has a little more, there's quality surrounded by a bunch of circles. It looks like a baby's toy, right? Okay? I don't know. But this is why some people say that there is nothing of substance to total quality management. In fact, there are some things of principles in total quality management. Total quality management also includes total productive maintenance. And I've got some pictures of commercial locating pins. So if you go in a machine shop and they're building a piece of tooling for a manufacturing facility, many times you have to have the parts fit and register so some stamping press or something can come down and hit them. And so they have these little locating pins with all kinds of different shapes on the top. And the story here is a General Motors plant. And it's a story about Bill Fonte, who was one of the early LFM graduates from like 1995. Bill had a 1.8 Tqm at like the University of Syracuse out of 4 in zoology. And he had gone to work for General Motors. There was a vice president and a senior vice president at General Motors who thought Bill was wonderful. Bill could go out on the factory floor and he could get those hourly workers to work. He was just a very personable Italian from New York, okay? And so they decided they wanted to send him back to the LFM program. I was on the admissions committee for the LFM program in the early 90s, and people looked at Bill Fonte with his 1.8 Tqm at a zoology at Syracuse, and they laughed. I said, well, wait a second. You got a member of the governing board who's a senior vice president at General Motors, and you got this other guy, and you respect these people, and they say Bill is wonderful. What's wrong? Well, he could never pass our classes. And that's what they turned down his admission, even though he was a fully sponsored GM employee, okay? These guys liked him so much, Bill got into the mechanical engineering department. And Bill took some courses. He got straight A's. The professors were asking if he would be their TA in their class because he had done so well, okay? So they put him up for LFM the next year. And the professors from engineering departments in the Sloan School, we already turned him down. I said, wait a second. Why did you turn him down? He had a 1.8 undergraduate Tqm. He can't handle MIT. What do you mean he can't handle MIT? He's got a 5.0. He's the TA. And you all know him. He's one of the most personable people around. That's one of our low points at MIT. We don't always have personable people. But Bill was just a very gregarious, everybody liked him. That's why General Motors liked him. He could work with people, okay? Well, I beat up on that committee for several sessions, and they finally said, okay, we'll admit him. He came in, he was the leader of his class. He's just a natural-born leader, okay? So I often tell my students that if you ever have a problem, you go out there, you took my class, I'll give you some free advice, free consulting. Just give me a call if you run into a problem. We're friends now, right? So about a year and a half later, Bill's sent to the Linden, New Jersey manufacturing plant where they're making Chevy Blazers. Sent him there because, hey, this is New Jersey, just like the Honeywell plant in New Jersey that made the plastic film with bad shitter. I mean, not the best employment relations. And Bill calls me up and he tells me about this welding problem. This is on the hinges of the Chevy Blazer. And they weren't getting good welds, good arc welds. And I said, well, Bill, what's the ground? With electrical ground. I gave him some points. And he said, you go check them. So about a week and a half later, he calls me up, Tom, could you come down? I said, well, Bill, did you check the things I asked you to check? Well, no, but I'd really like you to come down. I said, well, I said you can ask for some free advice, but I'm not going to pay to go down. Oh, we'll pay for your airfare. But we don't have any money to pay you as a consultant. Okay, Bill, you're a friend. I told you I'd help you. You pay my airfare. I'll go and fly into Newark and come see you. I walk in. We walk up to the machine. It's break time. There's no one at the machine. And I go up and look at it, and there's oil all over the electrical ground. I mean, just because the parts are metal parts that have to be welded, but they had to be stamped first, and so they still got the lubrication. I said, Bill, no one's degreased these parts. Oh, you're right. And Bill actually tried to pick one up, and it slipped out of his hand. It was so oily. Okay. I said, you can't get in a good electrical ground through oil. I said, well, and about that time, the hourly worker who runs the machine comes up, and we introduced ourselves, and I said, these things always this oily? He says, oh, no, these are pretty clean compared to what I usually get. This is a true story, folks. And so I said, well, how are you getting any welds? He says, oh, I got this rag over here. I just wipe it off every now and then. He wipes the oil off, okay? So you could have degreased the parts, and then you could have made a weld. You don't usually try to weld through oil, just in case you don't know much about welding. I mean, most welders know it. The hourly worker probably knew it. Then we go around back, and here's a whole rack of these. These are hoods that they're welding the bracket that holds the hinge on the hood. And I go over and say, well, let's look at these. And I said, well, there's a defect there. Well, there's a defect there. There's a defect there. And Bill said, oh, well, that's just a rack of defective parts that we've made. We're just storing them to get a repair done. I said, oh, okay. And this particular weld was a spot weld. And there were some parts there, and the guy wasn't there. They were, because he was out fixing parts or something. And I tried to pick up one of the parts, put it in the fixture with the locating pins, okay? And it slipped out of the fixture and fell on the floor. I picked it up to try to put it in again. It slipped again. And Bill says, well, let me try it. He puts it in, it slips on the floor. I said, Bill, look at that locating pin. The locating pin, which was supposed to be a simple cylinder, looked more like this. It was worn away. This is a hardened steel locating pin. Okay? Probably took a year or more to wear away like that. This is a question of, did they have any maintenance in this plant? So I said, well, Bill, okay, see if you can get the parts degreased. See if you can get somebody to replace the locating pin, and let me know what happens. He said, oh, Tom, I want to give you a tour of the plant. Oh, okay. I was there. Might as well take a tour. You always learn something on a tour. And this is an example of Charlie finds. There's $100 bills located all over the floors of these factory plants. I mean, you have to remove the grease of the oil. You got to take care of the locating pins. And we go up, and it turns out, he says, I want to show you this hinge on the rear lift gate of the Blazer. He says, we got a galvanized hinge, galvanized steel hinge. And they're welding it, and they're getting a lot of porosity. Well, Bill, you always get porosity when you weld steel through galvanizing because the zinc vaporizes and blah, blah, blah. And he says, well, yeah, but I need to fix it, Tom. It's his job was to fix these problems. And I'm starting to look at it. I said, well, Bill, this is on the inside of the vehicle. Why are you galvanizing this hinge? I don't know. So we kind of left it. He was going to find out why they galvanized it. Turned out there was no need to galvanize it. When he pointed it out to the engineers, they took away the galvanizing and saved $250,000 a year. They still had a hard time paying my $220 airfare, but they finally did. Okay? So there's sometimes the $100 bills are larger than $100. Okay? But it's just a question of going out there and using your common sense. Okay? Now, not everybody knows you can't weld through zinc. You knew that. What's your background?
Material science.
Material science, okay.
In Italy, we studied that for corrosion problems. So.
Okay, so you had galvanized things for corrosion problems. Anybody else? Were you nodding at me? No, okay. Anybody else knew that that was a problem? But you don't have to go that far. In fact, they've done a study over at the MIT Industrial Liaison program where a company calls up, they paid $100,000 to belong to MIT's Industrial Liaison program, and they found it takes 1.5 phone calls on average to hit the right professor. The officers over there kind of know who we are, and they'll call up and say, I got a company that's got a problem with this, can you help them? And you might say yes, or you might say no, but you ought to call Professor so-and-so. And on average, it's very rare they have to go through 3 phone calls. On average, it's 1.5 phone calls to find the right person who knows the answer. Okay? The answer is usually there in your system. In fact, students used to ask me, you're a consultant, okay? And actually, I guess I had told them the story that you, as a consultant in manufacturing for a company, management brings you in because the engineers in the company have been unable to solve the problem. And the worst thing you can do from the engineer's point of view is to solve the problem in the conference room, okay? It kind of makes the engineers look sort of not so swift, right? And so you want to solve the problem. Now, some people don't want to solve the problem. Some consultants would just love to come back for a few more visits. This is why we have healthcare costs that are through the roof, okay? Doctors can solve your problem in 1 visit, but they don't. They solve it in 10 visits. And it turns out they make more money that way, okay? I know this because I have a son who is an athletic trainer, and he can solve the person's problem in 1 or 2 visits. And he says, okay, you're done. You don't need me anymore. And he's having a hard time building up his business because he doesn't have people continuing to come back. Okay, but that's another problem. I'm getting into why the healthcare system is dysfunctional. But I go into a company. I said, I listen to the problem. Management tells the problem. Then the engineers are supposed to tell you the problem. But you find the engineers don't always tell you the whole problem because they don't really want you to solve it right away. They'd like someone to solve it, but they don't want to look stupid that you know the answer without even going out there. So what do? And the student said, I don't know. I said, what you do is you go out there. You ask for a tour of the factory. And while you're on the tour of the factory, you find some time to go up to the foreman and say, what's wrong? And the foreman tells you what's wrong. He knows what's wrong. This is the machine he works with every day. Okay? But he's not necessarily the most articulate person in the world. So you translate what he said into managementese, engineering doublespeak, or whatever you want to call this. You go back in the conference room and say, well, I think, and you tell him what the foreman said. And that's why the big consulting firms say the definition of a consultant is someone who borrows your watch, tells you what time it is, and then keeps it. Okay? Okay, that's enough for today. I'll see you tomorrow.